For psychology undergraduates, statistics might be like baking, like making baguettes. You do need good ingredients, a good recipe, a fair amount of practice, but the results could be t-test, chi-square test, scatter plot. Welcome to the lectures. Good morning, everyone, and welcome to the online lectures of data analysis and statistical inference. In this lecture series, we will cover several topics, and we've collected them in modules so we can have a discussion class right after each topic, each big module. So within the first module, today we will learn about design and basic concepts of empirical studies, and then we will learn about descriptive statistics, the central limit theorem, and normal distributions. This is the first big chunk that is basically covering descriptive statistical methods and design. Okay, so let's dive in. There are some basic concepts we will have to learn and understand and then use in order to make useful designs and empirical study plans. The very first and very important is the unit of observation. Okay, so these are cases, and for example, just students, if you're examining their anxiety, or flowers, if you're interested in how many leaves they have. So basically something that's defined as a unit of what you're observing, what you're empirically testing in your study. Of course, we're also interested in their characteristics, but these are the variables. Okay, so don't mix these two up. It's very important to make good distinctions between them. We will practice this a little bit. From the units of observation and variables, you can put together your data set, your case variable data matrix, and it has a special design, which is important when you use statistical programs. Now, about variables, we will learn about nominal, ordinal, and scale type variables because they're also important to determine what kind of statistical test you can use in your analysis. So basically, the main goal of statistics, why we use it, is because we're lazy. We talked about this last time in the introductory consultation time. And so psychologists typically take a good sample, a random enough, big enough sample, examine it, and conclude their solutions for the populations. The basis of doing this is formulating the hypothesis a priori of data collection and the whole analysis part. Okay, so these are the steps that we will cover today. And let's start by these main terms that we have to talk about later on. Observational units, which could be, as I said, subjects or anything, couples, words, bugs, basically anything that you're observing in your study. It's important that the population, by definition, is all of these observational units, whereas the sample is just a very carefully selected part of the population. It has to be random, independent, big enough, and representative. Let's stop here for a moment. Random, meaning that if you're examining a class, for example, do not pick the people who raise their hands or who are sitting in the first row. Just, pick from here and there to, for example, ask for an opinion. We also talked about this last time. It also, the units also have to be independent from each other. So probably it's a good idea not to pick, let's say, twins if you're interested in let's say, the student's opinion. Okay, it has to be big enough. We also talked a little bit about power analysis. How big is big enough? Bottom line, the bigger the better, but there's a stop limit. Somewhere you have to stop, and it's also a good idea to set this a priori of your whole data collection procedure. And most of all, it has to be representative. Once you're talking about, let's see, high school students, it's probably not a good idea to revert to only a single high school. Probably it's a good idea to monitor more specimens, more units of observation, basically students from different high schools. Okay, then we have the characteristics or features of the observational units, variables. For example, students have sex, male or female, they have age, they belong to different groups, let's say good students who perform well, students who don't perform that well, students who are part of a group or Facebook, I don't know, something, or people who are not, and many other characteristics. You have to pick your variables that are relevant to the hypothesis you're testing, because the aim is to be able to draw conclusions from the population based on the sample, as we've said. So you have your data, you do your statistics based on the hypotheses that are set, and you draw your conclusions. Now, I've been lying a little bit because sometimes you don't even need a hypothesis. We're at this descriptive statistics stage now. In this module, we will be dealing with this part of statistics. And sometimes only describing your data is enough to set a conclusion. For example, students of this high school class all got 5 on their closing exams, or a different class got a 3 on average, but the students' performance was very variable. Many of them got 1s, many of them got 5s, and in fact, nobody got a 3. That's also an observation. You can also draw a conclusion from it, and all you've used is descriptive statistics. Okay, let's practice now how to draft a good, an appropriate case variable matrix, and we can. It's not that difficult. I will show you through a couple of examples how we can do this. We always have a kind of hypothesis to begin with. For example, kind of sets our topic. I want to test a mindfulness intervention. Is it effective? Is it lowering stress levels? How will I do it? I will set a time course and I will measure cortisol levels and state anxiety based on a self-report before a 3-week mindfulness intervention in a group of people, let's say students, and I will also measure the same thing after a 3-week intervention. Question: what are the units of observation? This is always the first question that you have to put to yourself. So, guess? Well, if I'm observing students, then it's the students, the subjects, okay, who participate in the experiment. So one person is 1 unit of observation. In my case variable matrix, it will be a row, okay? If I have the subjects as units of observation, what could be the variables? Remember, I'm interested in how mindfulness is effective or not. Well, I had 2 ways of measuring it, if you remember. I had, and variables are, just a reminder, features of observational units. And here, the most important feature is anxiety level before the therapy. And I had 2 very different ways of measuring it. I had the objective cortisol level measurement, and I also had a subjective anxiety score. Okay? And if there's a before, then probably there's an after as well. Here again, I have objective and subjective scores. And of course, we could be interested in age and sex and things like that. These could also be variables in my case variable matrix. But now I'm concentrating on the specific hypothesis I've put to begin with, okay? And it didn't concern any sex differences. So what I'm going to put in my case variable matrix is the cases into the rows. Remember, we had the subject 1, subject 2, subject, etc., etc. And I had cortisol levels before and after, and self-report questionnaire data before and after the therapy. There's a slight mistake here. Subject number 1, then comes subject number 2, then 3, then 4, then 5, then 6, etc., etc. Okay, so I will correct that on the slides that I will give you afterwards. Okay, so my next hypothesis, just to keep practicing this, how to define the units of observation and how to set up the case variable matrix, is reaction time of adults is faster than that of children. It's a very straightforward hypothesis, easy to test. I give the subjects pictures of, let's say, a dog or a cat or an elephant, or not even animals, anything. And I'm measuring their reaction time, of course, in their native language. And I can see that this person says kutya for this picture in 837 milliseconds. Whereas a child might say wow, not even the name of the dog, but ruff, the barking, in a much more time, so a much longer millisecond time. And then collecting many of these responses, I can set up my database for, let's say, a picture naming study with reaction time. So I'm kind of giving you the hints. What are the units of observation here? Again, it's not difficult. They are the subjects, okay? But when we're setting up the case variable matrix, we have to think a little bit about the variables, okay? What could be the variables here? If I'm interested in whether the adults are different from the children in their reaction time, then probably it's age. That's a very important variable for the cases. Okay, so I have reaction time, what I'm measuring as a performance, and also age, which I group. Okay, the 23, 21, and 18 will be adults, and the 3 to 3 will be the children. And thus, I can make a very well-designed group comparison statistics to see what I see very obviously now from the raw data, that children are slower in naming these pictures than adults, especially if you give out the instruction for a speeded performance. They simply cannot keep it that well as adults. Okay, so this is kind of easy, I think. Now you're able to set up case variable matrices from a hypothesis. Okay, now comes the challenge. Okay, let's have a challenging quest still in this domain. It's a little bit more difficult, needs a little bit more thinking. If I'm saying, again, a very well typical cognitive study, naming actions is slower than naming objects. Okay, you can test this hypothesis many ways, but one very good way of going to this is having the subject name homonyms. Okay, here we have a single subject naming action and object pictures mixed in a speeded experiment. And again, we're measuring reaction time for fence, that's the output. But this fence will be much slower than this fence, probably because this is more frequent. We see this more frequently, use it more frequently. And of course, the picture might be more straightforward in this respect. Anyhow, question is the same. What are the units of observation here? And please think about this for a moment. Can they be subjects? No. Why? Because I have a single subject. I can't put him in the database. He's just, giving out the responses. So the responses are quite relevant, but similarly to our very first design where I had the before and after, the units of observations are not the responses themselves, it's the homonyms, it's both. Why? Because in the case variable matrix, I will have a fence, a slide, a map, etc., 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 a bet, okay? And I will collect reaction time for the object picture and reaction time for the action picture. And quite consistently, you will see that action pictures take a little bit more to react to. It's simply more difficult to comprehend actions than objects, and there are many other background things for it. But this is, bottom line, this is how your case variable matrix will look like. Okay, now we will turn to a different kind of problem. When we're dealing with variables, we have to know what type of variables they are. Why? Because it's important. You simply cannot use the same kind of statistics for different types of variables. So, let's learn this. We have a quantitative and qualitative type of variables, and we also can group them as nominal. It's a more detailed scale, okay? Nominal, ordinal, interval, and ratio, or scaled variables, okay? Both interval and ratio are scale type variables. Basically, when you're using JASP or SPSS, you're only interested in distinction between nominal, ordinal, and scale type variable. We are not even interested in whether it's interval or ratio. And we will move into what these are. The other way you can distinct between variables is based on the number of passable values, and there are discrete and continuous variables. Okay, so let's look at the first distinction, okay, the types. And these are the page numbers where you can find relevant literature in your course book. So here we have the qualitative variables, okay, and they are the nominal and the ordinal variables. And the nominal variables are probably the easiest. These are just categories like colors, red, blue, green, okay? Red is not better than blue or green. You cannot rank them. You cannot basically do anything with them. You can put them into these categories, okay, boxes. Now, contrary to the nominal type variable, the ordinals can be ranked. So, for example, university students are obviously more educated than high school students. So there's kind of a ranking to it, okay? And this is a big distinction against some statistics you can run on ordinal scales, which you cannot on the nominal scales, etc., etc. And last but not least, the quantitative type variables, or in SPSS these are called or JASP these are called the scale type variables, can be interval or ratio scales. With interval scales, the values can be added and subtracted. For example, 10 Celsius point colder, temperature is coder, but you cannot really say whether it's twice as cold as, let's say, 20 Celsius temperature. It doesn't feel that way. So it's kind of just adding and subtracting is possible with these type of variables, but ratio scales can actually multiply it and divide it. For example, in reaction times, if you're 3 times faster, you're 3 times faster. That's easy as that, okay? But as I emphasized before, the big distinction is between nominal, ordinal, both are qualitative scales, as compared to the quantitative scale type variables. We will have certain statistics to be run on qualitative as compared to quantitative scales. Okay, let's see another type of distinction. Sometimes the number of possible values in a measurement is limited. Okay, all nominal scales and almost all ordinal scales are like that because simply there's not limitless number of colors. You can have, even if many colors are listed, you have a discrete number of colors, okay? And about the types of education, well, you have lower, middle, and higher education, and that's it. Whereas continuous scales or continuous variables, there the number of possible values is unlimited, okay? It's a continuous scale, and of course, when you're actually collecting data, you will talk about milliseconds. Thus, your beautiful continuous scales with the fraction of milliseconds become discrete because you have to measure it somehow, okay? But in theory, these variables, for example, reaction time, is continuous, so you have to treat it that way. To be honest, this distinction is not that important since we're collecting data, and when we're collecting data, we always make discrete variables out of the continuous ones. Let me point your attention to a specific type of discrete variable. Dichotomous variables typically have 2 values. For example, somebody has the disease or does not have the disease. That's kind of a yes or no question, okay? And there are many others that have only 2 values, or you make them have 2 values. Somebody can smoke 1, 2, 3, 5, 6, and 30 cigarettes a day. But if it's 0, then that person is a non-smoker. If it's something else, a number, then that person is a smoker. So non-smoker or smoker is a dichotomous variable. Okay, let's have our last practice for this first very short topic. Let's categorize our variables based on the value types and number, and just hope that your wave comes in and everything will be splendid. Okay, so let's see the examples. Pulse rate, sex, weight, number of mistakes, body temperature, anxiety score, language proficiency. At this point and at these types of questions, I urge you to pause your video and try to solve the problems and then look at the answers. Okay, so pulse rate is a quantitative scale type variable, okay? Sex is nominal, basically male and female. You can have other categories, but it's still nominal. Weight is again scale type variable because, kilograms can be divided into many different fractions, and they can be ranked, they can be divided. If somebody is double the weight as last, let's say, year, then that's double, okay? Number of mistakes, scale type variable. Body temperature, again, scale type. Anxiety score, scale type. Although here I'm talking about a total score. Let's say you had 15 questions for anxiety, each rated from 1 to 5. When you sum these up, you arrive at a beautiful scale type variable. Okay, then language proficiency is ordinal. Why? Because lower, middle, higher proficiency. From the point of view of continuous or discrete, well, let's pick out the discrete ones. Okay, pulse rate, sex, not weight. Okay, weight is continuous. You make it discrete when you measure it in kilograms, but originally, and when you deal with it, it is continuous, and that's how you will draw your conclusion for it. Number of mistakes, on the other hand, is discrete because you can make as many as there were questions in the exam. Okay, body temperature again is continuous. Then you have anxiety score because scores are limited. Okay, as discrete, and of course language proficiency. Okay, last questions, tricky ones. Can we rescale a continuous variable into a discrete one? Here again, it's a good idea to pause, answer it. Of course we can. How? For example, I just did when I said that, for example, you could have the kilograms, your weight, which is some kilogram point something, so your kilogram can change with very, very, very small numbers. Still, when you actually measure it, today I'm this kilogram, tomorrow I'm this, next day I lost a kilogram. Okay, so I'm making it discrete ones. Next question. Can we rescale a ratio scale into a nominal scale? Good question. Can we? Yes, of course, we often do. Okay, not a ratio, but it's a ratio scale. How many cigarettes you've smoked each day, and you can make it into smoker and non-smoker. That's a good example. So it's a yes again. Can we rescale a nominal variable into an interval scale? Okay, we've collected, for example, green, blue, red, typical nominal variable. Can we make it into an interval scale? No, once you've collected green, blue, red, or smoker, non-smoker, you cannot change it back. You cannot have a redundant variable and make it into more details because simply you don't have the data. Okay, so it's a no. Okay, thank you for listening. That's all for this topic.